Hi everyone, I'm going to discuss graphs of sine and cosine functions, this time with translations. So there are two types of translations. One is horizontal translations. So when we say horizontal translations, the graph of the function, for example, defined by y equals f of quantity x minus d is translated horizontally in comparison to the graph of y equals fx. We also call horizontal translation class as a phase shift. Now, the graph of y equals f of x translated horizontally by d units going to the right if d is less than 0. On the other hand, it translated going to the left if d is greater than 0. So meaning, if it's horizontal translation, the graph moves horizontally either going to the left or to the right from its original location. And then the other one is vertical translations. So the graph of the function of the form y equals c plus f of x is translated vertically as compared with the graph of y equals f of x. So this time, the graph originally defined by y equals f of x will move either up or down by c units. So if c this time is greater than 0, then the graph defined by y equals f of x moves up. Otherwise, it moves down. So we're going to sketch the graph of original function, and we will observe the distance that it traveled horizontally or vertically. So we have to graph y equals sine quantity x minus pi over 3 over 2 periods. Take note, class, that the coefficient of x here will remain as 1. So therefore, we can say that the period remains 2 pi. But since there was a horizontal translation on this part, in comparison to y equals sine x for the given graph in example 1, originally the x coordinates are quadrantal by nature. I'm referring to the graph of y equals sine x. But as it moves horizontally by specifically pi over 3 units to the right, going to the right, then the x coordinates will no longer be quadrantal. And same with what we did, since the period is 2 pi, we will still divide 2 pi by 4, and we will be adding pi over 2 from the lower boundary until we reach the upper boundary. And with this one, we will begin with evaluating this inequality x minus pi over 3, which is less than or equal to 2 pi but greater than or equal to 0. In here, we consider one period interval in sketching the graph for the meantime. So this is from 0 to 2 pi. That's why we have 0 to 2 pi here, where 0 and 2 pi are included in this interval. Now, to simplify this inequality, we will be adding pi over 3 on all the sides of the inequalities. So plus pi over 3. So this will be cancelled. As a result, we have x is less than or equal to 7 pi over 3. So this becomes 7 pi over 3 as we add pi over 3 to 2 pi greater than or equal to, this time, no longer 0 but pi over 3. So from 0 to 2 pi, class, since there was a translation of pi over 3 units, so one period interval would start from pi over 3 to 7 pi over 3. But we want to sketch the graph over two period interval. So take note, class, that from pi over 3 to 7 pi over 3, the period here is 2 pi. Now, if you will just less the upper boundary 7 pi over 3 by pi over 3, really the value is 2 pi. Now, since we want to extend the graph, we want to add another one period from the left of that interval. So, the higher boundary or the upper boundary here will be pi over 3. And since we know that the period should remain 2 pi, so take note that the difference between the upper and the lower boundary is 2 pi. So as we less 2 pi by as we less 7 pi by 2 pi, we got pi over 3, which is the lower boundary. Likewise here, as we less pi over 3 by 2 pi, it has to be the lower boundary. So you can use your calculator like you are actually subtracting pi over 3, which is, let's temporarily consider pi as a variable, but we know that pi is a constant value equivalent to approximately 3.1416 for easy addition and subtraction. So like we want to less 1/3 by 2, and that would exactly be the coefficients of the lower boundary if we assume or assign pi as variable. So we have negative 5 pi over 3 here. Now, in our previous discussion, we sketched the graph of sine and cosine function over two period interval, which is from negative 2 pi to 2 pi. In here, we will still sketch the graph of sine and cosine function, observing translation over a two period interval. This time, since there was a translation, so this will start from negative 5 pi over 3 to 7 pi over 3. So, over the period, negative 5 pi over 3 to 7 pi over 3. So, what we will be doing is adding cumulatively pi over 2 from the lower boundary until we reach 7 pi over 3. I think we will be needing one more column here. We'll be needing one more column here. So, we have example. So we will start with the first value of the x coordinate, which is the lower boundary, negative 5 pi over 3. And then we will be adding pi over 2 cumulatively until 7 pi over 3. So negative 7, negative 5 pi over 3 plus pi over 2 is negative 7 pi over 6 plus pi over 2 again. So we have negative 2 pi over 3 plus pi over 2 again. We have negative pi over 6 plus pi over 2. We have pi over 3 here plus pi over 2. We have 5 pi over 6 plus pi over 2. We have 4 pi over 3 plus pi over 2. We have 11 pi over 6. And finally, plus pi over 2, we have 7 pi over 3. So originally, the x-coordinate in relation to the graph of y equals sine x is set of quadrantal values. But in here, since there was a translation, there was a horizontal translation specifically by pi over 3 units. So the x coordinates will be a different value. But as we go along the process here, as we evaluate x minus pi over 3 on the second row, where x is the set of all x on the first row, we will go back to quadrantal angles or quadrantal values. So this is like Negative 5 pi over 3 minus pi over 3. So we have negative 2 pi here. Negative 7 pi over 6 minus pi over 3. So this is negative 3 pi over 2. Negative 2 pi over 3 minus pi over 3. So we have negative pi here. And we have again, okay, so we have negative pi here. Okay. And then negative pi over 6 minus pi over 3, we have negative pi over 2. Pi over 3 minus pi over 3, so this is 0. 5 pi over 6 minus pi over 3, we have pi over 2. And then 4 pi over 3 minus pi over 3, we have pi. 11 pi over 6 minus pi over 3 is 3 pi over 2. And 7 pi over 3 less pi over 3 class is 2 pi. And it's easy for us now to evaluate or to complete the third row because this is just the sign value of the second row. And this is in relation again with unit circle, and negative 2 pi is coterminal with 2 pi. So the y coordinate in reference to unit circle is 0. So this is coterminal with pi over 2, and its y coordinate again in reference to unit circle is 1. So sine negative pi is 0. Sine negative pi over 2, which is coterminal with 3 pi over 2. So this is negative 1. Sine 0 is 0. Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi over 2 is negative 1. And sine pi is 2 pi. So we are now going to sketch the graph by plotting of this function by plotting each coordinate here. So this will be your x coordinates. And this will now then be our y coordinates. And in comparison to y equals sine x class here, so this is the graph of y equals sine x. So as we plot each point here, obviously you will agree that really y equals sine x translated horizontally by pi over 3 units going to the right. So for example, we have negative 5 pi over 3. So we can just like work on pi over 3 until 11 pi over 6. So this is like, so this is pi over 3, 0. And then 5 pi over 6, 5 pi over 6, 1 would be somewhere here. So this is 5 pi over 6, 1. And then 4 pi over 3, 0 is, so this is 4 pi over 3, 0. And then 11 pi over 6, negative 1 would be somewhere here, negative 1. Okay, so after 4 pi over 6, 11 pi over 6. So this is, I guess, pi over 6 less than 2 pi. Okay, so from here, going to negative 1. So most likely this is 11 pi over 6, negative 1. And this exceeds 2 pi. So let's say this is 7 pi over 3, 0. So if as we connect the points in a sinusoidal curve, we'll have this, going to this, and then going to this graph until this graph. Okay. And then we have negative pi over 6, like negative pi over 6, negative 1. So this is here. And then negative 2 pi over 3, 0. So we have here. So this is negative 2 pi over 3, 0. Negative 7 pi over 6, 1. So here. And then for a while. So this is negative 7 pi over 6, 1. And then negative 7 pi over 3, 0. Okay. Here. So again, connecting the points. So 7 pi here. So as we connect the points here into a sinusoidal curve. Now, this black curve is the graph of y equals sine quantity x minus pi over 3, while the blue curve represents the graph of y equals sine x. Now, from y equals sine x, the graph moved by pi over 3 units to the right, and this is now defined by y equals sine quantity x minus pi over 3. Okay, let's go to the next example. This time, we're going to sketch the graph of y equals cosine x plus pi over 4. Again, the period remains 2 pi. And we will be adding pi over 2. And we're going to consider or sketch the graph over 2 periods. So, originally, we sketched the graph of y equals cosine x with 2 period interval. So we begin with negative 2 pi to 2 pi. So here, we're going to solve for an inequality x plus pi over 4. And this is less than or equal to 2 pi, but greater than or equal to 0. And we will less pi over 4 to eliminate this pi over 4. So this will be cancelled. As a result, we have x is less than or equal to 7 pi over 4, which is greater than or equal to negative pi over 4. So meaning class, one interval period for the graph of number 2 is from negative pi over 4 to 7 pi over 4. Now, take note that the period will remain equal to 2 pi. How are we going to know? So you less the upper boundary by the lower boundary, and that gives us 2 pi. And again, say with the first example, we want to extend the graph over 2 periods. And we want to extend from the left of negative 4. So we'll have negative pi over 4 rather as the upper boundary of the first interval. And then again, we know that the period here is 2 pi. To obtain the lower boundary, so what we did, this is like 7 pi over 4 minus 2 pi gives us the lower boundary. Okay? So here, negative pi over 4 less 2 pi gives us negative 9 pi over 4. And subtracting negative pi over 4 by negative 9 pi over 4, we will still come up with a period equal to 2 pi. So meaning we're going to sketch the graph of number 2 from the interval negative 9 pi over 4 until 7 pi over 4. And we will be adding cumulatively pi over 2 from the lower boundary until we reach the upper boundary. And again, we'll be adding one column here. So we have negative 9 pi over 4 here. And we will add pi over 2. So upon adding negative 9 pi over 4 by pi over 2, we'll come up with negative 7 pi over 4. Add pi over 2, we have negative 5 pi over 4. By plus pi over 2, we have negative 3 pi over 4. Plus pi over 2, we have negative pi over 4. And then plus pi over 2, we have pi over 4. Plus pi over 2, we have 3 pi over 4. Plus pi over 2, we have 5 pi over 4. And plus pi over 2 will get 7 pi over 4. Okay? Now, as we evaluate x plus pi over 4, we'll go back with the quadrantal values. So, negative 9 pi over 4 plus pi over 4 is negative 2 pi. Well, negative 7 pi over 4 plus pi over 4 is negative 3 pi over 2. Negative 5 pi over 4 plus pi over 4 is negative pi. Negative 3 pi over 4 plus pi over 4 is negative pi over 2. Negative pi over 4 plus pi over 4 is 0. Pi over 4 plus pi over 4 is pi over 2. 3 pi over 4 plus pi over 4 is pi. 5 pi over 4 by pi over 4 is 3 pi over 2. And 7 pi over 4 plus pi over 4 gives us 2 pi. And then we'll evaluate the cosine value in reference to the unit circle. So, and negative 2 pi is coterminal with 2 pi. So, its cosine value is 1. And then this is coterminal with pi over 2. So, cosine pi over 2 is 0. And then cosine negative pi is negative 1. Cosine negative pi over 2 is coterminal with 3 pi over 2. So, this is 0. Cosine 0 is 1. Cosine pi over 2 is 0. Cosine pi is negative 1. Cosine 3 pi over 2 is 0. And cosine 2 pi is 1. So we are now going to sketch the graph of y equals cosine quantity pi over 4, x plus pi over 4. This will be our x coordinates. And this is our y coordinates. Now take note, as we compare the graph from y equals cosine x class, the graph will really move horizontally by pi over 4 units going to the left. Okay? So, this is the graph of y equals cosine x. So, I think until here, no? Here. If we use two intervals, so this would be the graph. Now, if we're going to sketch the graph of y equals cosine quantity x plus pi over 4, we'll come up with, I'll erase this part. Okay, so negative 9 pi over 4. So let's expand this portion. And if we start like with pi over 4, 0 here. So if this is 2 pi, this has to be pi. This is negative pi. So this is negative pi over 2. So pi over 2 would be, so for example, if this is This is negative 9 pi over 4. Okay, so we can start with negative 9 pi over 4. And this is 1. Okay. And then negative 7 pi over 4, 0. So approximately this is negative 7 pi over 4, 0. Negative 5 pi over 4, negative 1. So this is negative 5 pi over 4. And then negative 3 pi over 4, 0 is here. So this is again negative 3 pi over 4, 0. Okay, so we're done with negative 3 pi over 4, 0. So negative pi over 4, 1 would be here. And then pi over 4, 0 is here. 3 pi over 4, negative 1 is here. 5 pi over 4, 0 is, oh wait, this is pi over 2, approximately here. And then 7 pi over 4, 1. So here. So if we're going to connect the points into a sinusoidal curve, we have, sorry, okay. So from this y equals cosine x, the graph translated horizontally by pi over 4 going to the left. Okay? So it moves to the left. So d here is pi over 4, but the graph moves going to the left from y equals cosine x. So this time, let's proceed with vertical translation. And let's sketch the graph of y equals 2 plus cosine x. Now, still, the period remains 2 pi. And since the graph translated vertically, the x-coordinate will not be changed in comparison to the x-coordinate of cosine x. So the x-coordinates remains quadrantal, and we will make use, or we will sketch the graph over 2 period intervals. So we'll sketch this from negative 2 pi to 2 pi. And we will be adding pi over 2 cumulatively from negative 2 pi until 2 pi. Since the period is 2 pi and we want to come up with the quadrantal values. So we have here 2 pi, rather negative 2 pi plus pi over 2. So this is negative 3 pi over 2 plus pi over 2. This is negative pi plus pi over 2. This is negative pi over 2 plus pi over 2. This is 0 plus pi over 2. So this is pi over 2 plus pi over 2 becomes pi plus pi over 2, 3 pi over 2, and this equals 2 pi. So evaluating cosine value of each x here can be again associated with unit circle, and cosine negative 2 pi is 1. Cosine negative 3 pi over 2 is 0. Cosine negative pi is negative 1. Cosine negative pi over 2 is 0. Cosine 0 is 1. Cosine pi over 2 is 0. Cosine pi is negative 1. Cosine 3 pi over 2 is 0. And cosine 2 pi is 1. But this time, we will be adding 3. So, I don't know. This is 2, so this has to be 2. So from cosine x, we'll add 2 to obtain 2 plus cosine x. So now, the graph moves up by 2 units if we compare this with y equals cosine x. So plus 2, we have 3 plus 2. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 0 plus 2 is 2. Negative 1 plus 2 is 1. 0 plus 2 is 2. And 1 plus 2 is 3. Now, in comparison to y equals cosine x class, so this is the graph of y equals cosine x. Okay? So, let's make this 2 and this as 3. This negative 2, negative 3. Okay? So, let's sketch now the graph of y equals 2 plus cosine x and compare this with the graph of y equals cosine x. So, as you can see, they've got the same x coordinates. It's just that they will differ with the y coordinates since the graph will move up vertically. So, we have negative 2 pi 3. Okay? And then negative 3 pi over 2, 2 here. Wait, here. And then negative pi 1 here. And then negative pi over 2, 2. And then 0, 3 pi over 2, 2. And then pi 1. And then 3 pi over 2, 2. And then 2 pi 3. So if we're going to connect the points into a sinusoidal curve, okay? So this will go down and this will go down. So really, the graph moves up by 2 units. Okay? Next. So this time we're going to sketch the graph of y equals 1 plus sine 3x. And we're going to compare this with the graph of y equals sine 3x. Take note, class, that the period is no longer 2 pi. Instead, the period is equal to 2 pi over 3 since the coefficient of x or b is 3. So, the period is always divided by b. This time, the period will be 2 pi over 3. So, meaning, if we're going to sketch this over 2 periods, so we have negative 2 pi over 3 to positive 2 pi over 3. And we will be adding pi over 2. No, we will be adding like, let's add one more column here. We will be adding 2 pi over 3. So we will divide this by 4. So we're going to add 1/4. This is 1/4. 2 pi over 12. So we will be adding pi over 6 instead of pi over 2. So from negative 2 pi over 3, we will add pi over 6. So this is negative pi over 2. And then we will add pi over 6 again. So this is negative pi over 3. So we will add pi over 6. So this is negative pi over 6. We will add pi over 6. So that becomes 0. And then this is pi over 6. This is pi over 3. This is pi over 2. And this is 2 pi over 3. And then as we multiply each value of x here by 3, we go back with quadrantal value. So this is negative 2 pi 2 pi over 3 times 3. This is negative 2 pi. Negative pi over 2 times 3. This is negative 3 pi over 2. Negative pi over 3 times 3, we have negative pi. Negative pi over 6 times 3, we have negative pi over 2. 0 times 3 is 0. Pi over 6 times 3 is pi over 2. Pi over 3 by 3 is pi. Pi over 2 by 3. So this is 3 pi over 2. And 2 pi over 3 times 3 is 2 pi. And then we'll evaluate sine 3x. So meaning this is sine negative 2 pi. So this is 0. So this is 1. Sine negative pi is 0. Sine negative pi over 2 is negative 1. Sine 0 is 0. Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi over 2 is negative 1. And sine 2 pi is 0. And then, we will add 1 to sine 3x. So, 0 plus 1 is 1. 1 plus 1 is 2. 0 plus 1 is 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 0 plus 1 is 1. Negative 1 plus 1 is 0. So this will be our x coordinates. And this is our y coordinates. Oh, so this is 1. Okay. 1, 2, 1, 0, 1. Okay. So, in comparison to y equals sine 3x. So, this is the graph of y equals sine 3x in over 4 periods to eh. So, take note that from here until here covers 2 period. So, take note that y equals 1 plus sine 3x and y equals sine 3x has the same x coordinates. Negative 2 pi over 3, negative pi over 2, negative pi over 3, negative pi over 6, and so on until 2 pi over 3. It's just that they will differ with the y coordinates because the graph will move up by 1 unit. So, for example, if we begin with this point, so it will move by 1 unit here. So, this will be located here. So, this is negative 2 pi over 3, 1. So, negative pi over 2, 2 will be somewhere here. So, the graph will be, okay, pi over 6. Okay, here, there. So basically, the graph will move up by 1 unit. Now, if you want an exact graph of this, you plot the points of x and y here. Okay? So next meeting, I'll be discussing the graph of cosecant and secant function. So that's it for now.